Good morning.
Good morning.
How we doing?
The heat wave has reached the PNW.
Has it?
Yes, it begins today.
How hot are we talking?
91. So I know it's been way worse
I bet that feels
elsewhere.
pretty hot up there.
Yeah, but it does feel pretty hot up here, and lots of lack of air conditioning in this world. And then yeah, it doesn't get below 70 at night, and I think it's going to get worse like these next couple days. So all the windows are open, and I am definitely doing the shorts life until this is over.
Nice. Yeah, it's really not too bad when it gets hot during the day, as long as it cools off at night. And when it doesn't cool off at night, that is just the worst.
That is, yeah, harsh.
Yeah, normally in the Northwest we are lucky, and it generally does. But yeah, this next week is.
Yeah, this next week is just. Yeah,
is
we
the
finally
heat
got
dome
it.
coming back? Oh no.
It's not a full-on heat dome, but I think it's like approaching heat dome experience effectively because of the hot nights.
Yeah, I don't know if you saw the announcement, but at least in our Seattle Google office, they are going to be like preemptively running the AC to try to like get ahead of it. And I don't know why. That's the one thing that stood out to me. Like, whoa, we have to take proactive measures. Like this is, yeah, this is not good. And like I remember a long time ago, I was living in a condo, and they put up notices saying that like buildings in Seattle are not built to go over 88 degrees. And so like they might, if your place was comfortable below 88, just like when it crosses 90, beware. And it's true, like the AC just didn't work anymore or something. It was
yikes. Bad. All right, well, we've got a few things on the agenda. Why don't we get started? I will say that in our last meeting, Jeremy and I took an action item to articulate a decision tree around KubeFed. We spent some time talking about it, but we're not ready to give the decision tree yet. So we'll do that shooting for the next meeting in 2 weeks, okay? I think the first person on the agenda is Peter around stateful set migrations. Go ahead, Peter. And do you need screen share?
Yeah, that'd be great. I've been plagued by this bug on Zoom where I get muted if I present something. So.
Okay, I have enabled screen share. Go crazy.
Okay. Yeah, when I try to present, I get muted by the system. So would somebody else be able to present the slides linked in the agenda notes?
I can help you.
Awesome, thanks, Laura.
Because I will take over a screen share afterwards. So let me grab this and then share this. How's that?
Perfect. Okay, yeah, so today I want to talk about this concept of stateful set cluster migration and how it relates to SIG multicluster and a KEP that I've proposed for enabling this feature or enabling this use case. So next slide, please. So what is a stateful set migration and why do we care about it? So the goal for this idea is allowing a user to move a stateful set across clusters. Because of data gravity, it's often challenging to move a stateful set. You know, stateless is fairly easy to move. You can use like partial migration or directed percentage of traffic to a different cluster. But for stateful set, you know, if your database application or your stateful application relies on having a quorum available, having data available, it's difficult to migrate seamlessly. So some of the motivations here you could reach some scalability limits in a cluster. So say you have a multi-tenant cluster and you're reaching limits, particular limit of Kubernetes intrinsically, and you need to move particular applications out in order to decrease the load on that cluster. Maybe one of the applications that should be moved is a stateful set. The other motivations, tenant application isolation. So say a customer or a user has like a shared cluster. They want to move an application out to an isolated cluster. That's another use case. We also have this use case of features being end of life in Kubernetes. Sometimes new features are only available in a new cluster, and it really kind of depends on how you're initializing and running your clusters. But sometimes it's just not feasible to make a new cluster available or a new feature available to existing cluster. And then the final motivation here is making upgrades, providing more granular control. So rather than performing in-place upgrades where you upgrade nodes in the node pool, you upgrade control plane nodes, you could do this by moving a workload across clusters instead of upgrading the components within a cluster. So next slide, please. So what do we need to accomplish this? A stateful workload migration requires three things. Number one is networking. So in order for availability to be maintained, and just caveat this by saying, there's many ways to migrate a stateful set while incurring downtime today. You can take a backup of an application and then restore it in a different cluster. And that's often a use case for disaster recovery. But we're really looking here at the use case of maintaining availability during migration. So an application we need to have connectivity while it's being migrated. And for this use case, multi-cluster services pioneer headless services across clusters. So that's a solution here that could be used. The other aspect of migration is persistent volume claim migration. So the underlying data really needs to be moved. This could be accomplished either by accessing the same underlying persistent storage across clusters, if that's available to both clusters, or in the case where maybe clusters exist in different continents, in different data centers, this could be replicated. So, the data could be copied, transferred over the network, and then rehydrated as a persistent volume in cluster B. And then the final step is this pod and replica orchestration. So pods need to be migrated across clusters in a safe, available way. So you can think of this, maybe pods are moved over with respect to pod disruption budgets, or pods are moved one at a time, similar to how stateful sets get updated, like a rolling update. So this KEP that I've proposed, KEP 3335, there's a link there. It focuses on the mechanism for the third problem. So just this idea of being able to take a stateful set and control a subset of replicas to enable movement of these replicas to a new cluster. And next slide, please. So there's some caveats here in terms of what stateful workloads, what the requirements are and kind of the dependencies of a stateful workload it needs to fulfill before it can be migrated. So there's a few properties that I've scoped out here. So dynamic membership, you would need a way for applications to dynamically add and remove peers. Some applications don't natively support this and require a lot of manual configuration, or maybe some wrapper scripts around them to add and remove peers. Take MySQL, for example. If you're adding and removing replicas from a cluster set, it requires a database administrator to actually map different IP addresses in the cluster set configuration. And some of this stuff is handled by operators today, but it's not natively supported by the application. It kind of requires this external controller operator to modify configuration. Number two, flexibility in network identity. So the way that multi-cluster services work in for headless services is that the host names of particular pods have a cluster membership as part of the domain name. So if pods are migrated across clusters, the host name that will be used to address them from cluster A to cluster B will include that membership ID, and that will change. So this is kind of a divergence of the assumption within stateful set, kind of the original design, that each pod or each replica has a stable network identity. This is, kind of true because the individual pod's name doesn't change, but the fully qualified host name does because it's moving across a cluster. So the caveat here is that the identification of a particular replica for the application shouldn't be tied to the network identity, should be tied to the persistent volume that is migrated or the underlying data. And then finally, applications should be capable of finding peers. For example, this could be done through multi-cluster services DNS that spans clusters. Okay, next slide, please. So just going back to the core problem here, why isn't this solvable today? And what primitives prevent us from doing this? So kind of the issue is that we have two control planes if you have two clusters. So on the left, there's one stateful set controller, and on the right, there's another. And stateful set controllers, if you give them a set of replicas, they attempt to create those replicas from 0 to n. So there's no way to kind of surgically remove a particular range of pods and move that range over to another controller ownership. And so this KEP 3335 is a proposal to kind of add support for that, to enable this configuration of, say, you have an initial application, 3 pods, you want to migrate 1 pod, so you surgically remove app2, move it over to another cluster. And next slide, please. So this just goes over some of the proposed changes, and there's a link in the slides to the KEP if anybody's interested here, but the basic premise is adding a field to stateful set that enables a start and an end ordinal to be defined. And so you could take a subset of a stateful set's replicas and run them on another cluster. And because you have persistent volumes that could be migrated across clusters and networking that spans clusters, eventually this set of replicas across different clusters would reach a stable state. And once that's, you've maintained availability by making sure that there's sufficient quorum, excluding the replicas that you moved, and then once an application is stable, then you can proceed to move other replicas. Okay, next slide. So I think this is just a duplicate, but it contains the name of the KEP there. Next slide. So this is kind of a proof of concept of what cluster migration could look like. So in this case, like say for example, you're running a stateful set that includes Redis, and you want to migrate it across clusters. So you can imagine that, say in the cluster you're migrating from, you can install this cluster migration custom resource and specify the clusters you're migrating to and the stateful set you want to migrate. And given this specification, an agent that has access to both clusters, authentication to both clusters could conceivably migrate a stateful set using the KEP specification, as well as moving underlying resources or dependencies that the stateful set has. So moving persistent volumes in orchestration with moving stateful set replicas, or moving dependencies of the stateful set, like config maps or secrets. And as long as there's networking that's spanning both clusters, the stateful set could continue to operate as one logical application. Okay, next slide. So here I'm just reiterating the core problem here of, what one stage of moving one replica would look like. So left side, you have a stateful set, 3 replicas. Next slide, please. The logical flow would be, removing a replica, so scaling down stateful set in the cluster on the left. Next slide. And then bringing that replica back up using this new specification for stateful set in the right cluster. Next slide, please. So I wanted to showcase a demo of this proof of concept in action. Something that I think I see Alexis on the call. Alexis has done some amazing work here, prototyping this idea of stateful set migration. So let's play the video and then I'll talk through some of the steps. So yeah, I don't think there's any sound, but if you can maximize it. And just pause here. Actually, maybe go back a couple seconds. Okay, so I'll just explain the premise of what's happening here. There's a couple boxes, so let's start with the top left. Here we have a Redis cluster that's running 6 replicas, so it's running as a stateful set. Moving one pane to the right, we have a black cluster, and we're calling this red-black. Probably a lot of you are familiar with the concept of blue-green, but the connotation there is it typically involves spinning up 2 instances of an application and then cutting over traffic. In this case, we're migrating piecemeal, so pod by pod. So we're referring it by a different name, red-black, to kind of distinguish that concept. So yeah, we've moved one screen over. We're looking at the title that says black stateful set pods. So we can see in the second cluster, the black cluster, there's no pods running, and we'll start to see those being populated in this demo. One pane over, we see red cluster PVCs. These are persistent volume claims that exist that the stateful set is using in the red cluster. And then one more pane over, the black cluster PVCs. These have not been populated yet. So these will be migrated over as part of this orchestration. If we go one pane down, we can see the IP addresses associated with the headless service that this cluster has. So we can see 1, 2, 3, 4, 5. There's only 5. Maybe it's just not showing up. But yeah, these are IP addresses that are 10.104. They're associated with the red cluster, and we'll see these change to, I think, 10.8, which is the CIDR range for the black cluster. If we go one pane down, this one is just a memtier benchmark, making requests against this headless service. So we're just trying to showcase the fact that availability is maintained. And there's a bit of a caveat, I'll explain that later. And then finally, the bottom pane is this custom resource that is a cluster migration object. So it's kind of that proof of concept specification I showcased earlier. It contains details about the stateful set to migrate and the cluster to migrate from and the cluster to migrate to. Okay, so we can play the video here and just kind of, I'll talk through the results. So we see the stateful set's running in the red cluster. We're starting memtier. Here we're just creating that cluster migration object that specifies, let's move pods over or move the stateful set over. So can you pause it for a sec, Laura? The top rightmost pane, we just saw this black cluster PVCs get created. This was the underlying data moving over. So this was created very quickly, but the underlying data or the disks that was backing the stateful set, those weren't actually duplicated. What was moved over was the references. So the persistent volume, this persistent volume claim, those resources that actually reference the same underlying disk, those were just copied over. So the current status is lost because those objects were just created, but we're going to see the persistent volume or the volume controller in Kubernetes start to reconcile those objects and mark the status as bound. Okay, we can play again. So bottom pane, stateful set migration initialized correctly. We're starting to move pods one by one. So we can see a new status, the migration is progressing. And you'll see kind of in the second bottommost pane, there's a connection error. So this does happen when there is connectivity lost to a particular replica. But typically it's a retriable error. A client can just communicate with another peer that it has. Okay, and yeah, we probably don't need to watch the entire thing, Laura. You can probably skip to like the maybe 70% through. We can just catch the tail end here. Maybe a little bit further. Okay, so now we've started to see that multi-cluster service being updated. So we see 10.8 IP addresses being reflected there. And I'm just restarting memtier. There's kind of it's kind of a deficiency of the memtier client. It only caches IPs when it initializes rather than fetching IPs dynamically. So as soon as critical mass of IPs migrate in the underlying headless service, or the cached IPs are no longer connectable, then it fails to actually make requests to the application. But yeah, that's kind of the demo there. So eventually migration is complete. Now we have the application running on the new cluster, and it's just up to the Kubernetes administrator, the application administrator, to kind of clean up those resources and now maintain that application in the block cluster. Okay, so yeah, I think that's my last slide here, but I just kind of want to showcase this use case. You know, we think it's beneficial for having an alternative to an in-place upgrade, or having to, you know, maybe potentially have control plane downtime, or, you know, take the risk of rolling forward a control plane with having less control but rolling it back. So having this option to kind of migrate your workload, workload by workload, with a stateful set, you know, enables an administrator with more flexibility to be able to move workloads around across their set of clusters. So I'm just going to open the floor. Any questions people have, any things I should clarify or kind of talk about further?
So what happens if the cluster that is receiving the pods that the pods are being migrated to experiences like disruption? Does the migration halt? Is it sensitive to protecting quorum of the service running in the stateful service?
Yeah, that's a really good question. So it definitely is affected by connectivity issues, or, you know, potentially there's resource constraints in the new cluster you're migrating to. So the orchestration, the demo, it verifies that, or I guess it only progresses to moving new replicas if it deems that the system is stable, or the application is stable. So that means that, you know, the new replicas that have been brought up in the new cluster, they're running and they're ready. So, you know, using those liveness and readiness probes. So, you know, say in the case that, you know, there's complete disconnectivity and all of a sudden you're left with a subset of, or less than majority quorum in the old cluster, you know, we just have a network petition and the orchestrator would pause orchestration.
Okay. How about if you run an upgrade and the ingress of the receiving cluster is disrupted? Like one of the hosts running an ingress. That may not be the case in GKE, but like in a vacuum, say that I have some hosts that are part of the receiving cluster that are maybe not like modeled in the pod disruption budget. Like how about dependent services that also run within the cluster?
So you're saying like a dependent service that a stateful set application would need to function?
Yes. Yep.
Yeah, so I think that would be handled through health checking of the application. So, if this is a dependency, it's really, if this causes the application to all of a sudden experience become not ready, that would be kind of be up leveled to the controller that is moving replicas over.
Okay.
But yeah, I think there is kind of this conflict of, if you are performing a migration while there's an upgrade happening, you can get into these, tricky situations of you've just scheduled something and then all of a sudden your underlying resource gets disrupted.
All right. Well, I don't want to eat up all the time. Thanks. And very cool demo. I see Jeremy's got his hand up.
Yeah, like kind of following on that set of questions, I think there's a lot of different forms of readiness and what readiness actually means in Kubernetes, right? Like pod readiness doesn't necessarily mean the application is functioning properly. And I think, Paul, that's probably what you were touching on with the ingress. Like if ingress is down, pods can all be ready, everything's good, you can still talk to the cluster, but it doesn't mean anyone can talk to the new pods. I guess what would it take to plug into more of the facilities Kubernetes has, like pod disruption budgets, to kind of have a little bit more awareness at that controller level about what's going on? And I mean, awesome demo. I'm really excited about this, and I think this is definitely the kind of problem that this SIG needs to be solving. Expanding on what we've done with multi-cluster services, figuring out how to expand that to stateful workloads. But what do we need to do to make this a little bit more generally applicable?
Yeah, that's a good point. So I kind of think there's kind of two ways, like either bottoms up through pod readiness gates, tacking on to like existing readiness gates that pods have to kind of ensure the health of a pod holistically, rather than just the application is like the binary itself or the container itself is running. And then there's kind of this like overall health of an orchestrator, maybe being more aware of what's going on in the cluster, or what's going on in an application level, that could potentially pause or try to auto heal migration.
Cool. Yeah, let's. I also don't want to eat up all the time. I know we have more on the agenda today, but let's keep working on it, and let us know what you need from the SIG to make more progress.
Okay. Well, thanks everybody.
All right, Laura, I think you're next on the agenda.
Cool. All right, I had two things I wanted to mention. One was about last meeting, we had talked about id.k8s.io and our need to rename it, and there had been some mailing list call outs for brainstorms and then a survey. So I wanted to go over that a little bit. I have the survey results here, which is full of divisiveness or not a clear winner, though I think this problem is very nuanced, so I think we knew that might be the case. But the way that I organized the survey, just a quick overview, was to ask people for their top preference, which is extremely split of the 12 options that were provided from the brainstorming sheet, and then also ask for individual feedback, which was optional. So not everybody provided the individual feedback, but people could give comments and also score each individual item, whether they love it, like it, hate it, or undecided. Personally, I trend very much when it comes to an API naming to avoid hatred. So I'll highlight that hatred is orange, and just how orange things can get. For just a quick visual orange check. But in my reading of this, and I'll publicize all of the results too, so people can look at it some more. But I think in the category of things that are least hated is here we have cluster.clusterset.k8s.io. Here we have clusterid.k8s.io, and then one more to highlight up here. Ooh, here it is, clusterid.clusterset.k8s.io. I know the red is kind of scary, but red is actually like it. So
We need more love in this, SIG.
yeah, there's not a lot of love here. Well, here's a blue.
Remember, this is computers and the internet. If you like
Right.
it, effectively you love it.
You love it. Yeah. Okay. So anyway, so I kind of wanted to highlight, and also I'm pulling a little bit from all the comments too, because it's a lot to go over all at once, but there is some interest in this idea of sort of like property dot scope dot, general suffix as like the trend. So that was something to recommend cases where the more specific property details were before the sort of scoping mechanism in this naming convention, which is one thing to recommend, for example, clusterid.clusterset.k8s.io. And there's also some interest in keeping it simple, which I agree in principle, but I know we're in a hard time here. And then one other thing I want to highlight in terms of skipping over cluster.clusterset.k8s.io, the other least hated thing, clusterid.k8s.io. One thing I'm sort of worried about this is I don't think this gets across the thing we wanted, which was this ID is relevant to this cluster while it's in a cluster set, or at least that it has specific restrictions while in a cluster set. And I don't think that this really improves over id.k8s.io in that sense. So while it was widely liked, I don't know that this achieves our goals. So I'm prone to dropping that. So I'm leaning around based on like absorbing all of this into my brain, cluster.clusterset.k8s.io and clusterid.clusterset.k8s.io, which was the one they're not perfectly near each other, but up here. The hyphenated stuff was less beloved. I don't know if that's a hatred of hyphens or anything else. But yeah, so I wanted to give kind of this overview. I know it's kind of complex. And I think I can publish this data, and then to some degree, it's a bit up to API review, which is kind of like Tim Hawken is my API reviewer for this one. But I would like to open the floor to any more observations of this now that I gave a bit of a preview of what the raw data looks like, and if there is anything else on people's minds here.
I definitely agree with you about clusterid.k8s. I think that it's just a more verbose version of ID.k8s.
Yeah.
Just as confusing. Although I think the fact that people like it suggests that people still want ID.k8, or like we do need to solve the ID situation.
Yeah, maybe. I left id.k8s.io out of the survey entirely because that's what we were getting away from, but that might have been interesting.
I don't think we can't use id.k8s because we are not trying to solve the general purpose ID yet, but
sure, yeah.
I just see this as more suggestion that we need to. Personally, I lean the way you lean. I think it works. I don't think I'm super opinionated, but we were going to have clusterset.k8s.io be the cluster set ID. So this seems in line with that. Right? If clusterset.k8s.io is the cluster set ID, then cluster.clusterset would be the cluster ID within that. Those are my 2 cents.
It seems like cluster.clusterset.k8s.io is the least maligned.
Yeah, when it comes to the least hated, it received, out of 6 responses, it received no hatred. There's some undecideds, but.
Oh, I misread. I thought the green was love it.
Green, no, blue is love it.
Mm.
So we're not in love, but we're not allergic, I guess.
Yeah, does it still have least maligned status, do you think?
Yeah, I think it has least malign status.
It's the
because
only non-hated,
it's
right?
the only one that has no hatred. Whereas cluster ID.clusterset.caseio, which is sort of my other, is in the same trajectory, does have some hatred.
Now, I'm just curious. I'm certainly not playing devil's advocate, which I philosophically disagree with as a useful tactic, but I am very curious nonetheless to know what is the most maligned.
Yeah, I didn't pull it all the way. I started doing some V lookups in the background that had some null averaging
see.
errors I didn't resolve in time. But yeah, in terms of like massive orange amounts, cluster set number ID
Cluster
was a
set
bit
member ID.
divisive. This is a massive orange for multi-cluster dash cluster set dash ID. I think that was a lot of
Yeah.
typing people don't like. MC dash ID, again, like the hyphens, I feel got really disliked. Another MCS dash ID, we had talked a little bit that this might be too specific.
Yeah.
And then again, a hyphen cluster set dash ID received a lot more hatred in terms of orange share and
Seems
ID
like
dot cluster set.
cluster.clusterset.cates.io is the de facto winner to me personally. I don't know if anyone else agrees.
Right, in terms of least hated.
Mm-hmm.
Yeah, I think this would agree. Nobody hates it. People either don't care or they like it. That's fine.
Cool. Well, yeah, so as mentioned, my like personal opinion for API, like when we're discussing ergonomics, is least hatred. So I trend that way for my personal rubric, but I will publish all of this on the mailing list so people can take a look some more and say something there, but I'll provisionally suggest that so that Tim and I can talk about the next round of API review in this context.
Awesome.
Great. And then the other thing I wanted to mention today is
Do you have a deck?
Oh, I don't have a deck.
That was
Would
a
you
joke.
like me to provide you a
It's
deck?
just a joke. You more oftentimes have a deck than not.
I know.
But today you had to deck by proxy, right?
I did. I know. I didn't prepare a deck. I was so nervous, and then I got to share Peter's deck anyway, so I'm happy.
What a relief.
Thank God. Okay, the other thing I want to mention is that Gateway API I'm not sure if it's the project meeting or there's been some talk of like spinning up a new meeting or not, but anyways, the important part I wanted to say is that Gateway API has a doc about using the Gateway API for east-west traffic, and they're actually discussing it today at 3 p.m., which is on the SIG network calendar. And so this is an exploration doc. There's a lot of stuff in here. And in particular, this is an interaction between the Gateway API from SIG network and like the larger service mesh community. So there's a lot of requirements in here, especially the list of requirements was in here somewhere that oh, here we go, some use cases that have a lot more detail about the type of information that service meshes want to share for east-west traffic to enable their more sophisticated features. But I just thought it was probably important to bring up to this group, and the MCS API is not mentioned in here at all. So just wanted to put this on the radar. I'm going to stop by this if I can later and take a look at this some more. But encourage anybody else to take a look at this too if you didn't see the Slack chat or otherwise hear the rumblings about it.
And I'm one of the co-organizers of this.
Oh, hi.
It's hi.
Hey.
Excited to see this on the agenda and to hear that you'll plan to be coming to this. And yeah, I very much would love for it to include perspective on potential extensibility to like service import, service export type use cases as well. Yeah, so that's exciting, and it is planned to be a like working group duration type initiative. So it's a like sub project of Gateway API. So it'll be a recurring series of meetings. I linked the meeting notes doc in the notes here on Tuesdays on alternating times to accommodate a wider range of time zones, hopefully. Yeah, so looking forward to seeing folks, anyone who's interested, and chatting further on.
Awesome.
Cool. All right. So that's what I wanted to talk about.
All right.
And
I think that we're talked through. Thank you, everybody. Have a great rest of your Tuesday, and we'll see you next time.
Thanks a lot.
Take
See you
care.
all in a couple weeks.
Bye-bye.
Thanks.
bye.